Good morning to all. Heartily welcome to all for today's session. In the earlier session, we have discussed the topic Norton's theorem. Under this topic, we have understood the subtopics Introduction to Norton's theorem, Statement of Norton's theorem, Equivalent circuit diagram of Norton's, Steps or procedure. What are the steps are used to solve the electrical network using Norton's theorem, and simple problems. I solved 3 problems. Okay, these are things we had discussed in the previous session. What is the statement of Norton's theorem? Norton's theorem statement states that any linear two-terminal bilateral network can be replaced by an equivalent circuit consisting of a single constant current source and parallel with a resistor. This is the Norton's theorem statement. Equivalent circuit diagram. Norton's equivalent circuit diagram. Short circuit current IN is in parallel with RN. The load is connected. Then load formula IL equal to IN into RN divided by RN plus RL. Means current division rule प्रकार ನಾವು formula ಬರೀತೀವಿ. What are the steps are used to solve the electrical network? Step 1, remove the load resistor temporarily and mark the terminals. Second step, calculate the IN by find the short circuit current between the marked terminals. Third step, replace the voltage source by short circuit and current sources by open circuit and their internal resistance. Step 3, calculate the RN between the marked terminals. Step 5, draw the Norton's equivalent circuit diagram with the load resistor is connected. By constructing Norton's equivalent circuit diagram, the two important parameters are required. One is short circuit current, that is IN. Another one is RN. Both are connected in parallel, again parallel with load resistor. That is the Norton's equivalent circuit diagram. These are things we had discussed. I solved 3 problems. Okay. After knowing all this, let us move towards solve some more problems, applications and limitations we'll discuss. Okay, in previous session I solved 3 problems. Continue with the next problem. Problem number 4. Find the current through resistance RL equal to 6 ohm using Norton's theorem. Okay, 9 volt source is given, 3 ohm, 4 ohm, parallel with 6 ohm, RL is given. Okay, What is the step 1? Step 1, remove the load resistor, mark the terminals and short it AB. Okay, see the circuit diagram. Load ಏನಿತ್ತಲ್ಲ ಅದನ್ನು remove ಮಾಡಿದ್ದೀವಿ and mark the terminals A and B and short it. There exists short circuit current. Okay, ಈ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಮಾಡಿದಾಗ ಅದರ ಪ್ಯಾರಲಲ್ ಏನು 4 ohm ಇದೆಯಲ್ಲ, it does not affect. There is no current flow through 4 ohm because maximum current flow through short circuit only. That's why you just neglect that 4 ohm. In the circuit only 4 ohm, 3 ohm is left. Then total current is nothing but short circuit current. Only one loop ಬರುತ್ತೆ ನಮಗೆ 4 ohm ಹೋಯ್ತಂದ್ರೆ. Therefore IN equal to V by R1. V is 9 volt divided by 3 ampere. Step 2, replace the voltage source by short circuit and its internal resistance. Voltage source ಏನಿತ್ತಲ್ಲ ಅದನ್ನು ಶಾರ್ಟ್ ಮಾಡಬೇಕು. RTH is nothing but RN observed between the marked terminals. And here 3 and 4 ohm are connected in parallel. 3 into 4 divided by sum of these two resistance, it is 7. 3 into 4, 12 divided by 7, then Rn is 1.7 ohm. Okay, in step 2 we got IN. In step 2 Rn ಸಿಕ್ತು. Okay, next step, draw the Norton's equivalent circuit diagram by using IN and Rn values. IN is 3 ampere, Rn is 1.7 ohm, RL is load is given 6 ohm. Calculate the load current by using formula IL equal to IN into Rn divided by Rn plus RL. IN is 3 into 1.7 divided by 1.7 plus 6. 3 into 1.7, it is 5.1. 1.7 plus 6 is 7.7. After simplification, equal to 0.66 ampere. It is the load current. Problem number 5. Find the current through resistance RL equal to 6 ohm using Norton's theorem. In second problem solve ಮಾಡಿದಾಗ same ಇದೆ, but values are changed. Battery volt vary this supply. Okay, load resistance 6 ohm is given. Okay, step 1, remove the load resistor and mark the terminals and short it AB. ಈ ಮಾರ್ಕ್ ಟರ್ಮಿನಲ್ ಶಾರ್ಟ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ನಮಗೆ ಏನಾಗುತ್ತೆ, there exists short circuit current, it is maximum. ಅದರ ಪ್ಯಾರಲಲ್ ಏನಿದೆ ಅಲ್ಲ ರೆಸಿಸ್ಟೆನ್ಸ್ does not affect. You will just neglect the 3 ohm. ಓಕೆ, ಆ 3 ohm ಮಾಡಿದಾಗ ಸರ್ಕ್ಯೂಟ್ ಒಳಗೆ ಏನು ಉಳಿತೈತಿ ನೋಡ್ರಿ, ಅಲ್ಲೇ ಕರೆಂಟ್ ಮಾರ್ಕ್ ಮಾಡಿದ್ದೇವೆ. I equal to I1 plus I2. The I2 current is equal to IN. ಇದರಲ್ಲಿ 2 ಬ್ರಾಂಚ್ ಕರೆಂಟ್ ಕೊಡ್ತಾವೆ, I1 ಮತ್ತು I2. ಓಕೆ, ಸಮ್ ಆಫ್ I1 ಪ್ಲಸ್ I2 is equal to ಟೋಟಲ್ ಕರೆಂಟ್. ಫಸ್ಟ್ ನಾವು ಏನು ಮಾಡಬೇಕು, ಟೋಟಲ್ ಕರೆಂಟ್ ಕಂಡುಹಿಡಿಬೇಕು. ಟೋಟಲ್ ಕರೆಂಟ್ ಕಂಡುಹಿಡಿಬೇಕಂದ್ರೆ ಏನು ಮಾಡಬೇಕು, ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬೇಕು. ಟೋಟಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಬೇಕಂದ್ರೆ ಇಲ್ಲಿ 3 ohm ನೆಗ್ಲೆಕ್ಟ್ ಮಾಡಿರಿ. ದೆನ್ 4 ohm and 4 ohm are connected in parallel with 4 ohm. 4 ohm parallel with 4 means it is half 2. 2 plus 4 equal to 6 ohm. The total resistance 6 ohm. Therefore, total current I equal to V by RT. 18 by 6, that is 3 ampere. I is 3 ampere. Okay, then how much current flow through 4 ohm? That I2 is equal to IN. Okay, therefore here apply current division method, or direct you can write I2 value is 1.5, because I1 current flow through 4 ohm, I2 is also flow through 4 ohm. Equal resistance are in parallel. Okay, the total current, sum of these two currents means equally current will divide, because resistance are equal. Directly you can write half of that total current, otherwise you can use current division method. I N equal to I into 4 divided by 4 plus 4. 3 into 4 divided by 8 equal to 1.5 ampere is the IN current. Next, step 2. Replace the voltage source by short circuit and its internal resistance. Voltage source short moduli, the network becomes like this. Here 4 ohm parallel with 4 ohm, series with 4 ohm, again parallel with 3 ohm. 4 parallel with 4 plus 4. 4 parallel with 4, 4 into 4 divided by 4 plus 4, 16 divided by 8 is 2. 2 plus 4 is 6, parallel with 3. 6 into 3 divided by 6 plus 3, 18 divided by 9, Rn equal to 2 ohm. Okay, in step 2, we got IN. In step 2, Rn. The next step, draw the Norton's equivalent circuit. IN is 1.5, Rn is 2 ohm, RL is 6 ohm. Now, apply current division method. Therefore, IL equal to IN into Rn divided by Rn plus RL. Substitute the values. IN is 1.5, Rn is 2, divided by 2 plus 6. Rn is 2, RL is 6. 3 by 8 equal to 0.375 ampere. Next, sixth problem. Find the current through RL using Norton's theorem from the shown circuit. Okay, here two sources are given and load. Same problem. Already. Okay. Step 1. Remove the load. Mark the terminals and short it. Okay. And here add loops for the loop 1, loop 2 or I1 current flow through R1 resistance due to source V1. I2 current flow through E2 source through 60 ohm. Okay. Apply superposition. By applying superposition theorem, current in the shorted path is the algebraic sum of currents due to both sources. The second step, calculate the IN by finding the short circuit current between the marked terminals. Okay, here you consider in loop 1 IN dash, loop 2 I1 double dash. Okay, I1 current is getting due to source 100, means I equal to V by R. 100 divided by 50 equal to amps. I1 double dash equal to another source is 180 volt divided by 60 equal to 3 ampere. Okay, according to superposition, therefore the total short circuit current is equal to sum of both currents. IN equal to I1 dash plus IN double dash. 2 plus 3 is 5 ampere. IN is the 5 ampere. Next step, replaces the voltage source by short circuit, means the V set as a 0 and calculate Rn. Okay, here 50 ohm and 60 ohm both are connected in parallel. Rn equal to R1 plus R2, Rn into R2 divided by R1 plus R2 equal to, substitute the values, 50 into 60 divided by 50 plus 60 equal to 27.27. It is the Rn value. Draw the Norton's equivalent circuit. IN is 5 ampere, Rn is 27.27, RL equal to 15 ohm. Step 5. Calculate the load current by using current division rule. IL equal to IN into Rn divided by Rn plus RL. IN is 5 ampere into Rn is 27.27 divided by sum of Norton resistance and load resistance. Rn is 27.27 plus 15. After simplification, The load current is getting 3.23 ampere. Okay, problem number 7. Draw the Norton's equivalent circuit for a network having VTH equal to 6 volt, RTH equal to 2 ohm. Using source transformation, find the current through RL. Okay, here VTH is 6 volt, RTH is 2 ohm, RL is given. Okay, the ಯಾವುದು circuit diagram ನಿಮಗೆ ಅನಿಸುತ್ತೆ? You just think it. It is Thevenin's equivalent circuit diagram. This circuit diagram you just make into Norton's equivalent circuit diagram. That is the source transformation, voltage into current source. Vice versa, current source to voltage source. That's why this is Norton's theorem is the dual theorem of Thevenin's theorem. By using source transformation, IN equal to VTH divided by RTH. VTH is 6 volt divided by 2, 3 ampere. IN is 3 ampere. Then RN is equal to RTH. Thevenin's equivalent circuit diagram RTH ಏನಿರುತ್ತಲ್ಲ, the same value in Norton's equivalent circuit diagram carry ಆಗುತ್ತೆ, same ಇರುತ್ತೆ, both are equal. Then use formula IL equal to IN into RN divided by RN plus RL. 3 into 2 divided by 2 plus 10, 6 by 12. The load current IL becomes 0.5 ampere. Okay, 8th one. Same problem, only the load value is changed. Load value is changed. Draw the Norton's equivalent circuit for a network having VTH equal to 6 volt and RTH equal to 2 ohm. Using source transformation, then find the current through RL is 100 ohm. In previous problem source same ittu, then RTH same ittu, but load ಬೇರೆ ಇತ್ತು. It is about 10 ohm ಇತ್ತು, ಇಲ್ಲಿ 100 ಆಗಿದೆ ಅಷ್ಟೇ. The procedure same by using source transformation. IN equal to VTH divided by RTH. Then VTH is 6 volt divided by 2 ohm equal to 3 ampere. 3 ampere is the IN current. RN and R equal to RTH. RTH ಕೊಟ್ಟಿದ್ದಾರೆ, that is equal to RN. RN means 2 ohm. And ಆಮೇಲೆ ಅದರ ಪ್ರಕಾರ ಈಕ್ವಲೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ ಡ್ರಾ ಮಾಡಬೇಕು. IN ಬಂತು, RN ಬಂತು ಅಂದರೆ ಈಸಿಲಿ ಯು ಕ್ಯಾನ್ ಡ್ರಾ ದಿ Norton's equivalent circuit diagram, load as it is connected. Then calculate the load current. IL equal to IN into RN divided by RN plus RL. The IN is 3 ampere into 2 divided by 2 plus 100. 6 by 102 equal to 0.059 ampere. It is the load current. It is the load current. Okay, total previous session and this session I solved 8 problems using Norton's theorem. Next, applications and limitations. Applications and limitations. Applications, simply the circuit by transformation. Simply by transformation. Andra now source transformation in the voltage transformation in the current source convert ಮಾಡ್ತೀವಿ, vice versa. Okay, this is the main application. The applications and limitations are almost similar to Thevenin's theorem. The limitations. First limitation, Norton's equivalent is valid only to analyze for linear range of values of circuit parameters. Circuit parameters means certain range values of voltage and current is applicable. Certain range. After this Norton theorem is not applicable. Okay, this is the limitation. Second point, the power dissipation of the Norton's equivalent is not necessarily identical to the power dissipation of the real system. It means that Norton is theoretically analysis. Norton is theoretically analysis, but practically power dissipation is different. Practically power dissipation is different. Okay, this is another limitation. Okay, next, multiple choice questions. First one, the expression of Norton's current in the circuit shown below. The circuit is given, simple network. Okay, and four options are given. A is V by R1, V by R2, B, C is V into R2 divided by R1 plus R2, and D is V into R1 divided by R1 plus R2. Okay, which one is correct? ಹೆಂಗೆ ಕಂಡುಹಿಡಿತೀರಿ ನಾರ್ಟನ್ಸ್ ಕರೆಂಟು? ಅಲ್ಲಿ ಏನು ಮಾರ್ಕ್ ಮಾಡಿದ ಟರ್ಮಿನಲ್ ಅದನ್ನು ಶಾರ್ಟ್ ಮಾಡಿರಿ. ಶಾರ್ಟ್ ಮಾಡಿದಾಗ ಅಲ್ಲಿ ನಿಮಗೆ ಐ ಎನ್ ಸಿಗುತ್ತೆ. ಅದರ ಪ್ಯಾರಲಲ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇದೆ, ಅಲ್ಲೇನು ಎಫೆಕ್ಟ್ ಆಗಲ್ಲ. ಯು ಜಸ್ಟ್ ನೆಗ್ಲೆಕ್ಟ್ ದಿ R2. ಇನ್ನು ಸರ್ಕ್ಯೂಟ್ ಏನು ಉಳಿತು? R1 ಉಳಿತು, V ಉಳಿತು, ಆ್ಯಂಡ್ ಕರೆಂಟ್. ಕರೆಂಟ್ ಸರ್ಕ್ಯೂಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ IN. ದೇರ್ಫೋರ್ IN equal to V by R1. ಅಂದರೆ ಆನ್ಸರ್ ಈಸ್ A. Determine the Norton's equivalent current in the circuit shown below. Okay, circuit is given 30 volt, 10 ohm, 5 ohm. Options are A 2 ampere, B is 1 ampere, C is 3 ampere, D is 4 ampere. Which one is correct? Okay, short it. Short it means 5 ohm, you just neglect it. Only 10 ohm is left and 30 volt is given. Then apply Ohm's law, I equal to V by R. V is 30 divided by 10. It is 3 ampere. The answer is C. Determine the Norton's equivalent resistance of the following circuit. Okay. RN and conductor. Short the voltage source. Short the voltage source. RN is looking between the terminals. 10 ohm and 10 ohm are connected in parallel. 10 into 10 divided by 20, 100 divided by 20 means 5 ohm. Answer is A. Determine the Norton's equivalent resistance of the circuit. Circuit is given. The options are 10 ohm, 30 ohm, and 20 ohm, 15 ohm. Here also same. In third one ಮಾಡಿದಲ್ಲ ಅದೇ ರೀತಿ, ಬಟ್ ಒನ್ ಮೋರ್ ರೆಸಿಸ್ಟೆನ್ಸ್ ಇಸ್ ದೇರ್. ಏನು ಮಾಡಬೇಕು? ವೋಲ್ಟೇಜ್ ಸೋರ್ಸ್ ಶಾರ್ಟ್ ಮಾಡಿರಿ. The RN is looking into between the two terminals. 10 ohm and 10 ohm are connected in parallel. ಅಂದರೆ ಎಷ್ಟಾಯಿತು? 10 into 10 divided by 20. 100 divided by 20 is 5 ohm. That 5 ohm connected in series with 10 ohm. Options are 10 ohm, 30 ohm, 20 ohm, 15 ohm. Answer is 15 ohm. D is the answer. Okay, determine the Norton's current in the circuit. Norton's current ಹೆಂಗೆ ಕಂಡುಹಿಡಿತೀರಿ? ಶಾರ್ಟ್ ಮಾಡ್ತೀರಿ. ಓಕೆ, ಶಾರ್ಟ್ ಮಾಡಿದಾಗ ನಿಮಗೇನಾಗುತ್ತೆ? 10 into 10 are connected in parallel. It is 5. 5, 15. Okay. Five ohm, 15, 20. Voltage source is 20. 20 divided by 15 ನಿಮಗೆ ಕರೆಂಟ್ ಸಿಗುತ್ತೆ. ಆವಾಗ ಅಲ್ಲೇ ಟೋಟಲ್ ಕರೆಂಟ್ ಸಿಗುತ್ತೆ. ಆ ಕರೆಂಟ್ ಡಿವೈಡ್ ಆಗಬೇಕು. ಎಷ್ಟಾಗುತ್ತೆ ನೋಡ್ರಿ? 1.32 ಆಗುತ್ತೆ. That is the total current. that current equally divided. ಇಲ್ಲಿ 10 ಓಮ್ ಇದೆ, ಅಲ್ಲಿ 10 ಓಮ್ ಇದೆ, ಈಕ್ವಲಿ ಡಿವೈಡ್ ಆಗುತ್ತೆ. ಅವಾಗ ನಿಮ್ಗೆ ಆನ್ಸರು ಹಾಫ್ ಆಫ್ 1.34 ಅಂತಂದರೆ ಎಷ್ಟಾಗುತ್ತೆ? 0.67. ಆನ್ಸರ್ ಈಸ್ ಡಿ. Sixth one, determine the load current of the Norton circuit. Load current. The formula is IL equal to IN into RN divided by RN plus RL. IN is 1 into 15 divided by 15 plus 5, total 20. Yes, notary. Options are 1 ampere, 2 ampere, 0.75 ampere, 0 ampere. 1 into 15, it is 15, divided by 20, 15 by 20. Yes, right. 3 by 4. 3 by 4 means 0.75 ampere. Option is C. Answer is C. Determine the short circuit current. Okay. Not circuit or not circuit observe model. Here two sources are there, 6 volt and 4 volt. RL ಏನು ಮಾಡ್ಬೇಕು ನಾವು? ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಕಂಡು ಹಿಡಿಬೇಕಂದ್ರೆ ಲೋಡನ್ನು ರಿಮೂವ್ ಮಾಡಬೇಕು. ಏನು ಟರ್ಮಿನಲ್ಸ್ ಇದೆಯಲ್ಲ ಎ ಬಿ ಅದನ್ನು ಶಾರ್ಟ್ ಮಾಡಬೇಕು. ದೇರ್ ಎಕ್ಸಿಸ್ಟ್ ದ ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಕರೆಂಟ್. ಬಟ್ ಹಿಯರ್ ಅಪ್ಲೈ ಸೂಪರ್ಪೋಷನ್ ಥಿಯರಮ್. ದ IN loop on current flow through due to 6 volt and another current flow through due to 4 volt. ಏನು ಮಾಡ್ತೀರಿ ನೀವು? ಫಸ್ಟ್ ಲೂಪದ್ದು just apply Ohm's law. 6 divided by 2, 3 ampere, correct? And here 2 ampere. I1, I2 is sum of these two currents is equal to IN. 3 plus 2 is 5. Answer is D. Determine the Norton's resistance. Okay, here remove the load and short the voltage source. That is very important. When we are finding Norton's resistance or Thevenin's resistance in any electrical circuit, short the voltage sources and open the current sources. That point is very important. By finding RTH in Thevenin's theorem and here Norton's theorem. Okay, short the both voltage sources. Short ಮಾಡ್ರಿ, ಅಲ್ಲಿ ಲೋಡ್ ರಿಮೂವ್ ಮಾಡಿ ಮಾರ್ಕ್ ಟರ್ಮಿನಲ್ಸ್ ಇರ್ತಾವೆ. ಅಲ್ಲಿ ನಮಗೆ ಎರಡು ರೆಸಿಸ್ಟೆನ್ಸ್ ಆರ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ ಪ್ಯಾರಲಲ್. 2 into 2 divided by 2 plus 2, 4 by 4. ಎಷ್ಟಾಯಿತು? 1 ohm. ಇದೇನು ನೋಡ್ರಿ, ಆಪ್ಷನ್ಸ್ ಆರ್ A equal to ohm, B equal to 4 ohm, C equal to 1 ohm, D equal to 0 ohm. Okay, answer is C. Okay, find the Norton's current. Okay, this is Thevenin equivalent circuit diagram. Options are 2 ampere, 4 ampere, 8 ampere, 0 ampere. ಹೆಂಗೆ ಕನ್ವರ್ಟ್ ಮಾಡ್ತೀವಿ? ಬೈ ಯೂಸಿಂಗ್ ಸೋರ್ಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಷನ್. 8 ವೋಲ್ಟ್ ಕೊಟ್ಟಿದ್ದಾರೆ, ವಿ RTH ಕೊಟ್ಟಿದ್ದಾರೆ, VTH ಕೊಟ್ಟಿದ್ದಾರೆ. Then what is IN equal to V by RTH. 8 divided by 4, 2 ampere. Answer is A. Find the Norton's resistance. 8 volt RTH. This is Thevenin equivalent circuit diagram. What is the value of RTH? Sorry, RN, Norton's resistance. ಹೇಳಿದೆ ನಿಮಗೆ. Norton's resistance is equal to Thevenin's resistance. Here Thevenin's resistance is 4 ohm. Then what is the value of RN? Options are 4 ohm, 2 ohm, 12 ohm and 0 ohm. Which one is the correct? 10th. A is correct. A is correct. Okay. Thank you.